This is question number 33 from the book Pathfinder, chapter Kinematics, subsection Check Your Understanding. In a particular scene of a science fiction movie, a UFO is flying horizontally at a very high altitude with a speed u, that is eta times speed of light. The UFO is emitting sharp light pulses at regular and very small intervals. Find the speed of the UFO recorded by an observer on the ground at point O when the UFO appears at an angle theta with the vertical. Ignore relativistic corrections. So O is the position of observer. This is UFO, which is moving with speed u, and it is emitting pulses at regular intervals. And seeing those intervals of pulses, it's asked in the question, what is the speed observed by this observer? Now, this is a very interesting question based on the finite speed of light. The important point here is that the observer is not measuring the actual speed of the UFO. He is measuring the speed based on the arrival of successive light pulses. Now, since light requires time to travel, the recorded speed will be different from the actual speed. Let's see how. Now, this is the observer at point O. At this instant, the UFO is seen at an angle theta with the vertical. And suppose the first pulse is emitted when the UFO is at P1, and the distance of this point from the observer is r. A short time later, after an interval t0, the UFO reaches P2 and emits the next pulse. During this interval, small interval t0, the UFO moves a horizontal distance ut0, and because the interval is very small, the increase in the distance from the observer is also very small. Let that increase be delta r. So the second pulse is emitted from a distance r plus delta r. Now let us calculate when these pulses reach the observer. I shall assume that the first pulse is emitted at time t0. So emission of first pulse P1, it is assumed at t equal to 0. Now this pulse will reach the observer when light has covered this r distance, and it will take a time r by c. Now consider second pulse. It is emitted t0 seconds later. After emission, it has to travel a slightly larger distance, that is r plus delta r. Therefore, the arrival time of the second pulse is t0, the emission time, plus the time taken by light to cover r plus delta r. So this is the total time when the second pulse reaches the observer. Hence, the observer receives the two pulses with a time interval, that is t2 minus t1, which comes out equal to t0 plus delta r by c. So this is the most important observation. Although the UFO emits the pulses every t0 seconds, the observer receives them every t0 plus delta r by c time. So a bit larger time interval as felt by the observer. And this is why the observed speed is different from the actual speed. Now we are going to calculate this delta r. Look carefully at the velocity vector of the UFO. Its actual velocity is horizontal. Resolve this velocity into two components, u sine theta and u cos theta. One component is perpendicular to the line joining the observer and UFO. This u cos theta is perpendicular to this r, while u sine theta is in radial direction, in r direction. And this u sine theta will increase this r with the rate u sine theta. So it can be written mathematically like this: dr by dt is u sine theta. Now here dr means a small change in r, which is actually delta r, and dt means a small change in time, so that is t0. So I am just replacing dr and dt by their actual values, and this gives us delta r as ut0 sine theta. Now the final step is straightforward. The UFO actually moves a distance ut0, and this distance covered is felt by the observer in this time, t0 plus delta r by c. So the speed which he will calculate, the observer will calculate, will be the distance divided by this time. So that will be the apparent velocity of UFO, distance covered upon time, which the observer feels. Just put the value of delta r calculated earlier. get T naught cancelled, and put a U by C as eta. Okay, so this was a nice question because the time interval seen by the observer is a bit larger due to increase in the radial distance as the UFO moves, and that brings about a different velocity felt by this observer. Okay. This is a kind of Doppler effect, if you have heard this name, Doppler's effect, that the frequency of emission of light is not the same as the frequency observed by this observer. So that frequency change is bringing the change in time interval.